In the exciting world of machine learning, several basic concepts play a crucial role in understanding and manipulating data. Let's dive into some key terms and explore their practical implementation. 1. Mean. Definition: the average value of a set of numbers. It tells you the central tendency of the data. Practical implementation: calculate the average house price in a dataset to understand typical market value. Track the mean accuracy of your machine learning model across training runs. 2. Standard deviation. Definition: measures how spread out the data is from the mean. A low standard deviation indicates data clusters closer to the mean, while a high value suggests wider dispersion. Practical implementation: analyze the standard deviation of customer purchase amounts to understand spending variability. Identify outliers in your data that significantly deviate from the standard deviation. 3. Variance. Definition: the square of the standard deviation. It represents the average squared distance of each data point from the mean. Practical implementation: compare the variance of exam scores in different classes to evaluate score variation. Use variance as a regularization term in some machine learning algorithms to prevent overfitting. 4. Median. Definition: the middle value of a set of numbers when ordered from least to greatest. It's not sensitive to outliers like the mean. Practical implementation: analyze the median income in a city to get a more robust picture than the mean, which might be skewed by high earners. Compare the median house price in different neighborhoods to understand overall affordability. 5. Interquartile range, IQR. Definition: the difference between the 75th and 25th percentiles, representing the middle 50% of the data. It shows the spread of the central data points, excluding outliers. Practical implementation: assess the distribution of wait times in a queue by analyzing the IQR. Compare the IQR of exam scores in different subjects to evaluate score consistency. 6. Normalization and standardization. Definition: transforming data to have a specific mean and standard deviation, usually 0 and 1, respectively. This makes features comparable and improves the performance of some machine learning algorithms. Practical implementation: standardize features like height and weight before building a model that predicts lifespan. Normalize financial data like stock prices to compare values across different companies. Remember, these are just a few basic concepts. As you delve deeper into machine learning, you'll encounter a treasure trove of additional techniques and tools. But having a solid understanding of these fundamentals will equip you to embark on your data-driven adventures with confidence. Feel free to ask if you'd like me to expand on any specific concept or provide further examples of its practical applications in machine learning.